Hello class, welcome to Geometry Lesson 6.5, which is all about properties of special parallelograms. By the end of this lesson, you should be able to use the properties of, I use the plural rhombi rather than rhombuses. Your book is going to use rhombuses. Okay, so you should be able to use the properties of rhombuses, rectangles, and squares to solve problems. So first, I made this little chart for you to kind of help you organize the information that we've learned so far. So we've talked about polygons this chapter in 6.1, but then the rest of the chapter is focused on quadrilaterals, all of our four-sided figures. Now, with quadrilaterals, we have a few different types. So you can see kites and trapezoids are their own thing. They are not related to other quadrilaterals, so their own properties just are unique to them. But if you go over to parallelograms, you can see that there are a few figures that stem from parallelograms. You can have a more specific type of parallelogram, and that more specific type could be a rectangle or a rhombus. I have the plural there, rhombi, that I use, and then squares are even more specific. It's the most specific type of parallelogram that you can have. And, the thing I like about this chart is it helps you understand a little more about the properties of these. So if I am looking at a rectangle, that means that the rectangle has any of the properties of anything listed above it. So a rectangle is also a parallelogram, and it's also a quadrilateral. If I was looking at a rhombus is also a parallelogram, and it's also a quadrilateral. If I look at a square, then it is all of those things. It is a rectangle, a rhombus, a parallelogram, a quadrilateral. A kite is just a kite or a quadrilateral. It inherits properties of quadrilaterals, meaning it has four sides. And same with trapezoids. Trapezoids are their own thing, and it inherits from quadrilaterals. So if we're looking at a square, and I ask what are the properties of a square, you would list all of the properties that are unique to square, rhombus, rectangle, parallelogram, and quadrilateral. Okay, and I know that can be confusing and tough to remember, so you might want to draw yourself like a little chart with all of those properties. And this lesson, I'm doing things a little differently, just because I don't think the lesson is very easy if we don't talk about these things first. So I'm starting with the concept summary, which tells us about rectangles, rhombi, and squares. So if we look at that first column, rectangles, so remember, rectangles inherit everything from parallelograms and quadrilaterals. So a parallelogram has two sets of parallel sides, so that means our rectangle does as well. And since it's a parallelogram, that means that it has opposite sides that are congruent, and a rectangle, more specifically, also has all 90-degree angles in the corners, and the diagonals are congruent in a rectangle. So if I give you a parallelogram and I ask, is this a rectangle, you would need the 90-degree corners, which if you have the congruent diagonals, you know you have the 90-degree corners. So if you have congruent diagonals, so going all the way across, if AC is congruent to BD, that picture is a little deceptive. It kind of makes it look like the diagonals are cut in half and the halves are congruent, but if you look at the symbols, it's talking about the whole diagonal. Now, a rhombus also inherits everything from a parallelogram, but in order to be a rhombus, we know that our diagonals are perpendicular. Okay, so that means that our diagonals meet at a 90-degree angle in the middle of our figure, and those are, they also bisect each pair of opposite, angles. So if I have a rhombus, I know that this angle is going to be congruent to this angle, and this angle is going to be congruent to this angle. And it keeps going, right? All of these angles got cut in half by the diagonals. So a rhombus has more specific things about the angles inside of it. Then a square combines everything we just talked about from parallelograms, rectangles, and rhombi. So we have one last thing for a rhombus is all four sides are congruent. Our book never mentions that. They just expect you to know it from previous classes. So I'm going to remind you, a rhombus has four congruent sides. So then a square also has four congruent sides, and its diagonals are congruent. So the diagonals are congruent, and those diagonals meet at 90-degree angles. Okay? So that's how you know something is a square. And all of this information that I just said, you are going to use that to do lots of different calculations. So you really want to become familiar with those. So if we look at example 1, we want to find the diagonals for a rhombus. And I ask you, what is WY? Okay, so I want to think, if I'm talking about a rhombus, that means that my diagonals meet at a 90-degree angle. And, excuse me, I also know from a parallelogram that these diagonals are cut in half. So if I have 5 and then a 3 and then right angle, I can solve for this distance right here, and then I can double it to get WY. So the formula that we use to find a missing measure on a right angle is a squared plus b squared equals c squared, which is our Pythagorean theorem. So remember, a and b are the sides that form the right angle. So 3 squared plus x squared equals 5 squared. So I have 9 plus x squared equals 25. X squared equals 25 minus 9 is 16. And then if I square root that, I would have plus or minus 4. But since we're talking about distance, I get rid of the negative because we can't have a negative distance, and x just equals 4. So this distance right here is 4. That means this one's 4. And WY is 8 units. All right, so then this question is for you, and you want to find the angle, RPS. Remember, think about what we know about angles for a rhombus. Good luck. Hopefully for this one you remembered that for a rhombus the angles get cut in half, and the ones that are opposite of each other are congruent. They're the exact same. And if you looked at that blue triangle that I highlighted there, you can see that it forms an isosceles triangle. So that matches up with our previous knowledge that we knew. So if I want to solve that, I know there's 180 degrees in that highlighted triangle. So if I subtract 70 from it, I'm left with 110 degrees. And that 110 degrees has to be evenly split between the last two angles. So you are left with 55 degrees. So then here are some of those theorems that talk about the things that we discussed in our concept summary at the beginning of the video. So theorem 6-16 is if a parallelogram is a rhombus, then its diagonals are perpendicular bisectors of each other. Okay, so meaning they meet at 90 degrees and they cut each other in half. Then Theorem 617 is if a parallelogram is a rhombus, then each diagonal bisects a pair of opposite angles. That's what we used on that second example, that question that you guys just did. So go ahead and take a screenshot of these if you would like, and let's move on. All right, so then we have example 2 where we want to find the lengths and angle measures in a rhombus. So if I know that quadrilateral GHJK is a rhombus, and I want to find GH. Okay, so remember, in a rhombus, all of the sides are congruent, and then the diagonals are bisected. So these two purple segments are congruent to each other. So I have a 4x plus 3 for one of them, so I can say 4x plus 3, or sorry, not 4x plus 3, 2x plus 3, my apologies, equals 4x minus 7. The reason I'm going to do that is then once I solve that, I'll have an x value, and I can plug it into this expression over here to find the length of a side. And all of the sides are congruent on a rhombus, so I know that'll be the measure of GH. So if I subtract 2x from both sides, I have 3 equals 2x minus 7. Add 7 to both sides, I have 10 equals 2x. Divide both sides by 2, and I have x equals 5. And then if I plug that in, 3 times 5 plus 1 gives me 15 plus 1, or 16 units. So I set my bisected diagonal equal to each other, so I could find out what x was. Then I plugged it into this side over here because I knew the expression for it, and I knew that that hj is congruent to gh, so that's why I did that process. Go ahead and look at this example and see if you can solve for qt. Good luck. Hopefully to solve this one, you set the two congruent sides equal to each other to solve for y, and then plugged that into the measure of the diagonal, which is listed all the way on the outside here. And when you plugged it in, you ended up with 16, which was the whole diagonal. But if you read the question, we wanted to know qt, which is only half of the diagonal. So I took that full diagonal and cut it in half to get 8 units. So Theorem 6-18 is if a parallelogram is a rectangle, then its diagonals are congruent. Okay, so you can see this picture of the rectangle. We have all 90-degree angles in the corners. We have opposite sides are congruent. And we know that the diagonals are also congruent. Go ahead and take a screenshot of that if you would like, and let's move on. All right, example 3. We want to find diagonal lengths of a rectangle. So we know that Paul is training his horse to run the course at a pace of 4 meters per second or faster. Paul rides his horse from D to C, so D to C, and then to E, and then to B in 1 minute and 30 seconds. And we want to know, did he make his goal if this is a rectangular track? So the way that we can solve this is if I look at this whole triangle, I have a right triangle, and I know that this measures 192 because this one is. And I know this is 80 because this one is. So I have 192 squared plus 80 squared equals that diagonal squared. So if I do 192 squared plus 80 squared, I get 43,264 equals x squared. If I take the square root of both sides, I'm left with 208 equals x. So my whole diagonal, that whole purple line, is 208 meters. But if you look, my blue line only comes to half of it. So that means that I need to cut that 208 in half. So 208 divided by 2 is 104 meters. So if I add up the total distance that this horse ran, from D to C, it's 192 meters. From C to E, that's going to be 104 meters. From E to B, that's also 104 meters. So if I add all of those together, I get a grand total of 400 meters traveled. And if I divide 400 meters by the time, which is 1 minute and 30 seconds, which I'm going to convert to just seconds because he trained his horse in meters per second. So I'm going to do 400 divided by 90, because a minute and a half is 90 seconds. And if I do that, I have 4.4, and that 4 is repeating, meters per second. So that means that yes, Paul met his goal because he wanted his horse to run at least 4 meters per second. All right, this is the last question for you to do. So we have a rectangle with an area of 1,600 meters squared is 4 times as long as it is wide. What is the sum of the diagonals? Why don't you go ahead and see if you can solve this problem? I recommend drawing a picture, and good luck. All right, for this example, hopefully you ended up at 165 meters. Quick explanation of that. If you draw the rectangle, you should have had something that looked like this. And then if you solved for x, you should have gotten 20. Then if you drew in a diagonal, you would have a right triangle with a side length of 20. And then if I do 4 times 20, I get 80. If I do Pythagorean theorem with 20 squared plus 80 squared, I'm left with 6,800. If I take the square root of that, it's approximately 82.46. And that gives me one diagonal, but the question was, what is the sum of the diagonals? That means I need to add 2 congruent diagonals together. So 82.46 times 2 gives you the 165 meters. And the very last question, example 4, diagonals and angle measures of a square. So if we have figure WXYZ is a square, and we have WX plus XZ equals 92. What is the area of triangle WPZ? So if we start and draw the picture, that's what we would have. And since the figure is also a rhombus, because remember a square is a rhombus, rectangle, parallelogram, and quadrilateral, we know that the diagonals are perpendicular to each other. So I have a right angle there. And we know that WP and ZP are the base and height of that triangle, right? It's not the hypotenuse. The hypotenuse is the side that's opposite of the right angle. So then if I want to find the length of the diagonals, I know that since this square is also a rectangle, my diagonals are congruent. So that means that WY would equal XZ. My 2 diagonals equal each other. And therefore, each one would be 46 units, because I'm going to take that sum of them, that 92, and I'm going to cut it in half. Then, once I've done that, I want to figure out what the measure of WP and ZP is. I want to figure out what the lengths of these 2 sides are, because then I can find the area. So I know that WP is going to be half of WY. Remember, we learned parallelograms. The diagonals are cut in half, they're bisected. So half of 46 is 23. So I know that this measure is 23. And same thing goes for the other one. Those are also bisected, so this is also 23. So to find the area of a triangle is 1/2 base times height. So 1/2 times 23 times 23 is going to give us 264.5 units squared, and that is our answer. I did not write down a problem for you guys to do on this example, but if you have questions on this problem or anything from before in this video, please be sure to reach out for some help. I'd be more than happy to assist you. Have a great day.